Hi everybody. So welcome back again. So in this video we are learning about oblique projectile, and that is nothing but an introduction purely in this video. And also we will learn about path of projectile is to be shown as parabola. How we can do that we will see in this video now. So you can see the definition on the screen straight away. Oblique projectile: when a body is thrown at certain angle, and that angle, let it be theta, and that is not equal to 90 degrees, and that way it is thrown with horizontal, and it is also having some initial velocity, such a particle or a body is called as oblique projectile when it is thrown, right? So in that way we call it as oblique projectile. So let us visualize this whole thing with the help of a beautiful diagram. So how to draw this one, let us see. As we are saying that the projectile is nothing but motion of a particle along two dimension, right? So I would like to say two dimension is nothing but two axis. So one is horizontal, that is x axis, and another one vertical, that is y axis. So this is x and this is y. So motion along x-axis and motion along y-axis. So what does the definition of your projectile say? When a body is thrown at certain angle other than 90 degrees with a horizontal with some initial velocity, right? So it is being thrown now. So assume that the particle is thrown with some velocity. So like this. So when it is thrown with some velocity, I would like to give you this one. See, the velocity is this one. So at an angle, a particle is being thrown to you. Thrown with a horizontal and this theta. And say with initial velocity u. With some initial velocity u. When you throw a particle at an angle other than 90 degrees with horizontal, the particle covers along what you call x-axis as well as along y-axis, and it will take a path as we considered with assumptions. The path is going to be a parabola. So it will be in this way. You can see on the screen straight away. So u is your initial velocity straight away, and now here this initial velocity is making an angle theta to the horizontal. And what you can observe here, the velocity can have its components, right? As we already discussed that one, the components are straight away, see here, you can say like this, right? So a component along x-axis, say that it be ux, and this one you can write it as u cos theta, and a component along y-axis, this one you can write it as uy, and this one can be given as u sine theta, right? So now the particle is moving along this path, see here, like this, correct? And reaches this point over here, the ground at the same position here. And now there is one particular position where you will have the maximum, the particle reaches the maximum, right? So therefore this position, whatever this one, is called as maximum height attained by the particle. Maximum height attained by the particle. So now during its motion, let us consider a particular point over here. Okay, let us consider a particular point over here. See this one. So denote this point as some P. So at a point P, the velocity of the particle will be along tangent, right? Already we know this one, because for a curved path, the direction will be along tangential only. So say this is your tangential path, and say this is velocity v at that particular point. So again it is going to have two components, that is one component along horizontal vx and another component along vertical vy. Sorry for it. Yeah. So therefore at that particular point we are having Vx as well as Vy. Now you can say at maximum height. So already in motion under gravity we learned, right? So at the maximum height the particle will have vertical velocity 0. So therefore at this maximum position height, that is maximum height or maximum position along y-axis, the vertical velocity, component of vertical velocity is going to be 0, and here only one velocity will exist, and that is along x-axis, that is horizontal. Only Vx will be existing over here, and thus Vx is also parallel to this Ux, you can see from the figure. So therefore Vx can be easily or directly written as Ux. And again, if you want to consider one more point somewhere here during its path like this, so the same as usual, same old logic, that is directly the tangent direction will be the velocity direction, and then its components will be taken, one along horizontal, that is Vx, and another along vertical. Now but for this is downward motion, so this can be considered as Vy. So these are all what you call is the velocity components or velocity of the particle at different positions, you can just say. And all here everything done clearly. And see this angle, we can say now here is some different angle other than theta, that is alpha. And now if you see the position of the particle, see clearly, I would like to denote with the red one only. See this one, the position of the particle P in terms of coordinate, you can say simply, right? So this one is x at a distance of x, and here if you see this one vertically, it is at a distance of y, correct? So therefore this point P can be represented as x comma y. So if you want to say that represent this, I mean show the path of this projectile clearly as a parabola, so you need an expression in terms of x and y. So assuming that the particle P is at a, I mean projectile is at a point P x comma y after a time t. So let us assume there only it is being present, and have all the derivations whatever we can do further to express it in terms of x and y. Okay, so let us start our motion. And already we said, right, projectile is nothing but motion in two dimension, that is motion along x-axis and motion along y-axis, and two separately I can take directly. So I would like to consider here both the things separately. So now see here, along horizontal direction, okay, whatever all the parameters are there, I would like to consider all those things. So along horizontal direction, so the required parameters are, first one is initial velocity, correct? The first parameter we require is initial velocity, and that is given by Ux, and it is a component of initial velocity u, so therefore u cos theta. And then acceleration, so here the acceleration of the particle along x-axis ax will be 0, because you can ask me the net force along horizontal direction is 0. Since the net force along horizontal direction is 0 for the projectile, therefore the particle will have a 0 acceleration along x-axis. Is that clear? So done now. So now let us go into our concept straight away. So the displacement covered by the particle in a time t along horizontal direction is given by what? X final is equals to x initial plus, already we have written this one, right, uxt plus half ax t square. And what is this xi? Xi is nothing but displacement at t equal to 0. Where is the projectile at t equal to 0? It is considered to be at origin, so therefore xi is equals to 0. and say this x final is nothing but at position P, and we have written it as x. So therefore xfb x. So therefore you will be getting as x is equals to u cos theta into t, this is plus 0. So therefore x is equals to u cos theta into t, from which I can write an expression for t as x upon u cos theta. So the expression for t was written as x upon u cos theta. So this is all about your horizontal direction. So now let us go to the vertical direction and have the same equation straight away. So along vertical direction, done. So along vertical direction, the displacement covered by the particle is given by y. So let us take all the parameters whatever we require, as usual like previously we have done. So initial velocity, and that is nothing but a component of initial velocity along y-axis. So we have considered that one as uy, and say this one as now u sine theta. And now acceleration. So acceleration that we require along a y-axis, so that is ay, and already along y-axis mean vertical motion only, right? So if a particle is said to be executing in vertical motion, what we can say, it is under the influence of gravitational force of earth. So it will be always be trying to pull it downwards, right? So therefore acceleration is gained by a body which is due to the influence of gravitational pull of earth, and that one we call it as acceleration due to gravity. So therefore as the particle is moving up, the acceleration due to gravity is downward. So ay is considered as minus g. So now let us take as usual again. So y final is equals to y initial plus uyt plus half ay t square. As usual, as x initial is 0, similarly y initial also will be 0. So let us assume the things as usual again. So y is equals to u sine theta into t plus half into minus g t square. So now let us substitute. So substitute t is equals to x upon u cos theta in y. So therefore y is equals to u sine theta multiplied by x upon u cos theta plus into minus half g multiplied by x upon u cos theta whole square. So let us simplify. U and u get cancelled. You can see here straight away, this is sine theta by cos theta into x. This is minus half into g into x square by u square cos square theta. So therefore I would like to write this one as y is equals to x into tan theta minus, see here, g upon 2u square cos square theta into some this one x square. So let a is some arbitrary value I taken constant like tan theta, assuming a as tan theta, and say one more thing is b, take it as g by 2u square cos square theta. So our expression will become now as y is equals to ax minus bx square, which is a quadratic equation. So therefore it represents the parabola. So equation of parabola. So thus path of projectile taken is parabola. So hence proved, right children? Yes. So hope Everyone understood this one? So in our next video, we will see a problem on this path of projectile case, that is given in the form of y is equal to ax minus bx square, and they will be asking some requirements like what is the angle of projection, what is the initial velocity, etc, etc. So one problem we will see in our next video. So any doubts, please post in a comment section. Hope you enjoyed it. Thank you very much. Have a great day.